The Sun may engulf the Earth in 5 billion years. When its hydrogen supplies are exhausted, the star will turn into a red giant. At this stage, it will expand so much that it could reach the orbit of our planet. When the Sun enters its red giant phase, it will undergo a massive transformation. Right now, it is in a stable state called the main sequence, where it fuses hydrogen into helium. Once that fuel runs out, the core will contract and heat up, while the outer layers expand and cool, giving the Sun its characteristic red hue. The life cycle of our Sun. The life cycle of a star like our Sun is a multi-billion-year journey dictated by the constant battle between gravity, pulling inward, and nuclear fusion, pushing outward. Our Sun is currently a middle-aged star, having lived about 4.6 billion years with another 5 billion or so to go. The Sun began as a massive cloud of gas and dust called a nebula. Over millions of years, gravity caused the cloud to collapse and spin, forming a dense, hot core known as a protostar. Once the temperature at the center reached roughly 15 million degrees Celsius, nuclear fusion ignited. This is the stage the Sun is in right now. It is a stable, yellow dwarf. In the core, hydrogen atoms fuse to create helium, releasing a massive amount of energy. This process happens nearly 10 billion years. Gravity tries to crush the star, but the outward pressure from fusion keeps it stable. In about 5 billion years, the Sun will run out of hydrogen in its core. The core will shrink and heat up, causing the outer layers to expand significantly. It will grow to nearly 100 times its current diameter. It will likely swallow Mercury and Venus, and potentially the Earth. After the red giant phase, the Sun becomes unstable. It will pulsate and eventually blow off its outer layers into space. This creates a beautiful, glowing shell of gas called a planetary nebula. The Sun, as a cohesive star, ceases to exist at this point. All that remains is the Sun's former core, a white-hot, incredibly dense object about the size of Earth. Mostly carbon and oxygen. With no more fusion occurring, it will slowly cool down over trillions of years until it eventually becomes a cold, dark black dwarf. While the Sun will definitely change, Earth's fate depends on a high-stakes cosmic race between orbital migration and atmospheric drag. As the Sun reaches the end of its life, it doesn't just get bigger, it also gets lighter. During the red giant phase, the Sun will blow off about 30% of its mass into space via powerful stellar winds. With less mass in the Sun, its gravitational pull on the planets weakens. Like a tetherball on a loosening string, Earth's orbit would naturally spiral outward. Some calculations suggest Earth could move from its current 1 astronomical unit to about 1.5 astronomical unit, roughly where Mars is now, potentially staying just ahead of the expanding Sun. Even if Earth moves outward, the Sun's outer atmosphere, the chromosphere, will be incredibly thin but vast. If Earth becomes even slightly submerged in this thin gas, it will experience drag, similar to how a satellite eventually falls back to Earth because of air resistance. This drag would slow Earth down, causing its orbit to decay. Additionally, tidal bulges created by Earth's gravity on the Sun's surface would actually pull Earth inward. In this version of the story, Earth is eventually swallowed and vaporized within the Sun's core. Their technical, survival vs. biological, survival. While scientists argue over whether the rocky ball of Earth survives, there is a consensus on life. Life on Earth is doomed much sooner. In 1 billion years, the Sun's brightness will increase by about 10%. This is enough to trigger a runaway greenhouse effect. The oceans will evaporate, the atmosphere will be stripped away, and the plate tectonics that regulate our climate will seize up. Even if the physical planet avoids being swallowed in 5 billion years, it will be a scorched, airless cinder, much like Mercury is today, long before the Sun reaches Earth's orbit. When discussing the end of the world, scientists distinguish between the physical existence of the planet and its ability to support life. While the Earth might technically exist for 5 billion years, its biological clock runs out much sooner. Biological survival, the 1 billion year limit. Biological survival refers to the window of time in which Earth can maintain liquid water and a stable atmosphere. This window is closing faster than you might think. The Sun isn't just getting older, it's getting brighter. Every billion years, the Sun's luminosity increases by about 10%. In about 1 billion years, the increased heat will cause the oceans to evaporate. Water vapor is a potent greenhouse gas, which will trap even more heat, creating a feedback loop. As the Earth heats up, silicate weathering, a chemical process that traps CO2 in rocks, will accelerate. This will strip the atmosphere of CO2 so effectively that plants will no longer be able to perform photosynthesis, leading to a total collapse of the food chain. Technical survival refers to the Earth as a physical, rocky object. This stage doesn't begin until the Sun actually runs out of hydrogen and becomes a red giant. The Sun will swell past the orbits of Mercury and Venus. As mentioned before, their technical survival depends on whether the Sun's mass loss, which pushes Earth away, happens faster than the Sun's tidal pull, which drags Earth in. If Earth survives the red giant phase, it will orbit a white dwarf. However, it would be a zombie planet, a cold, dark, radioactive rock with no atmosphere or magnetic field. Biological survival, their 1 billion year limit. Biological survival refers to the window of time in which Earth can maintain liquid water and a stable atmosphere. This window is closing faster than you might think. The Sun isn't just getting older, it's getting brighter. Every billion years, the Sun's luminosity increases by about 10%. In about 1 billion years, the increased heat will cause the oceans to evaporate. Water vapor is a potent greenhouse gas, which will trap even more heat, creating a feedback loop. As the Earth heats up, silicate weathering, a chemical process that traps CO2 in rocks, will accelerate. This will strip the atmosphere of CO2 so effectively that plants will no longer be able to perform photosynthesis, leading to a total collapse of the food chain. Technical survival refers to the Earth as a physical, rocky object. This stage doesn't begin until the Sun actually runs out of hydrogen and becomes a red giant. The Sun will swell past the orbits of Mercury and Venus. As mentioned before, their technical survival depends on whether the Sun's mass loss, which pushes Earth away, happens faster than the Sun's tidal pull, which drags Earth in. If Earth survives the red giant phase, it will orbit a white dwarf. However, it begins roughly 5 billion years from now. At this point, the Sun has exhausted the hydrogen in its core and has transitioned into a red giant. As the Sun's core contracts and its outer layers expand, its diameter will increase by a factor of about 200. Mercury and Venus will be the first to be consumed. Their orbits will be completely swallowed by the Sun's outer atmosphere, the photosphere. The Sun's surface will extend out to approximately $1.10, 101 million miles. Since Earth currently orbits at 1.0 astronomical unit, the planet would technically be inside the Sun. The reason scientists aren't 100% sure Earth will be destroyed is due to stellar mass loss. As a red giant, the Sun becomes leaky. Powerful stellar winds will blow away its outer layers, causing the Sun to lose about 30% of its total mass. According to the laws of orbital mechanics, if the Sun has less mass, its gravitational grip weakens. This would cause Earth to drift outward, potentially reaching a safe distance of 1.5 astronomical unit. Even if Earth moves further away, a phenomenon called tidal drag could pull it back in. Earth's gravity will create a bulge on the Sun's bloated surface. Because the Sun rotates slower than Earth orbits, this bulge will act as a gravitational brake. This friction could slow Earth down enough to decay its orbit, causing it to spiral inward toward a fiery end despite its initial escape. If Earth manages to survive both the expansion and the drag, it will witness the final death throes of the Sun. The Sun will puff off its remaining outer layers, leaving behind a glowing gas cloud. The Sun will shrink into a cold, dense core the size of Earth. Earth would remain as a frozen, airless rock, a zombie planet orbiting a dim white dwarf for trillions of years.